have seen that multiplying any decimal number by 10 shifts each digit in the number one column to the left. In the last lecture, we used this trick to convert decimal numbers with a finite number of digits into fractions. In this lecture, we will see how to convert repeating decimal numbers into fractions. Repeating decimal numbers have one or more digits after the decimal point that repeat forever. As an example, let's convert a decimal number with one infinitely repeating digit into a fraction. The first step is to eliminate the infinitely repeating digit. We do this by first multiplying the number by 10 to shift it one column to the left, and then subtracting the original number. Since both numbers in this example have an infinite number of repeating fives, this eliminates all the repeating fives after the decimal point. We know that our original decimal number is equal to some fraction, but we don't yet know what that fraction is. However, we do know that when it is subtracted from 10 times itself, we get 5. Let's write this statement as an equation. 10 times the fraction minus the fraction equals 5. It is possible to write this statement more simply. Subtracting one thing from 10 things leaves 9 things. So instead of writing 10 times the fraction minus the fraction, we can simply write 9 times the fraction. Since both sides of the equation are equal, we can divide each side by the same number and they will still be equal. Let's divide both sides by 9. Notice that on the left side of the equation, the fraction is multiplied and divided by 9. This leaves its value unchanged, so we can cancel out the 9's on the left side of the equation. We are left with an equation which says that the fraction is equal to 5/9. We have converted our repeating decimal number to the fraction 5/9. Let's try this again with a repeating sequence of 3's. As we did in the previous example, we eliminate the one repeating digit by multiplying by 10 one time and then subtracting the original number. This eliminates all the repeating 3's to the right of the decimal point. So 10 times the fraction minus the fraction equals 3. We write this as an equation which we can simplify to say 9 times the fraction equals 3. We then divide each side of the equation by 9 so that the 9's on the left side cancel. This equation tells us that our fraction is equal to 3/9. Of course, the fraction 3/9 can be reduced to 1/3. So we have converted this repeating decimal number to the fraction 1/3. Now, instead of a single repeating digit, let's convert a decimal number with a repeating sequence of 3 digits. Since there are 3 repeating digits to eliminate, we must shift the number 3 columns to the left by multiplying it by 10 3 times. This, of course, is the same as multiplying by 1,000. We then subtract our original number, which eliminates the repeating digits. Now we write this as an equation. 1,000 times the fraction minus the fraction equals 123. 1,000 times the fraction minus the fraction is the same as 999 times the fraction. And dividing both sides of the equation by 999 cancels out the 999 on the left. So our fraction is equal to 123/999. Let's see what happens with the repeating decimal number 0.1 followed by an infinite number of sixes. Since there is only one repeating digit, 6, we shift the number one column to the left by multiplying by 10 one time and subtract the original number. This eliminates the repeating sixes, and we are left with 1.5. We then write the equation 10 times the fraction minus the fraction equals 1.5, which we can simplify to 9 times the fraction equals 1.5. Dividing both sides of the equation by 9 eliminates the 9's on the left, and we see that our fraction is equal to 1.5 over 9. But we have a problem. A fraction's numerator and denominator must be integers. We can solve this problem by multiplying the top and bottom of the fraction by 10 to create two integers. This gives us 15/90ths, which can be reduced to 1/6. So this repeating decimal number is equal to 1/6. As a final example, let's reduce a number that has the repeating sequence of digits 142857. Since there are 6 repeating digits, we shift this number 6 columns to the left by multiplying it by 10 6 times, which is the same as multiplying by 1,000,000. We then subtract the original number. This eliminates all but one copy of the repeating sequence. We are left with the integer 142857. We then write the equation 1,000,000 times the fraction minus the fraction equals 142857. Using the same logic as before, the left side of this equation can be simplified to 999,999 times the fraction. Dividing both sides of the equation by 999,999 leaves us with an equation which says that our number is equal to the fraction 142857 over 999,999. Using the factoring techniques we learned in the lecture on reducing fractions, this scary-looking fraction can be reduced to 1/7. So we have discovered that this repeating decimal number is equivalent to the fraction 1/7. This concludes our lectures on fractions.